Hello everyone, this is Spencer Snowling from Hydromantis, and I'm welcoming you to today's webinar where we will be discussing Toxchem, our air emissions and faint predictor and simulation package, which is primarily used in industrial wastewater treatment, but we have some uses in the municipal wastewater field as well. So my name is Spencer Snowling. I'm VP of Business and Product Development here at Hydromantis. I'm very happy that you could join us for this product demonstration today. And as I mentioned, we're going to be talking about Toxchem. This is a package which we've had as part of our suite of industrial wastewater tools now for about 8 or 9 years. It was a package that was originally developed by a company called Enviromega, which we acquired a number of years ago. And we've picked up that product and sort of overhauled it and developed it and given it new life over the last 6 or 7 years. And we continue to develop this product, and we'll have version 4.3 coming out later this year. So as I mentioned, the purpose of Toxchem is that it's a package that predicts the fate of organic compounds, particularly volatile organic compounds that are of interest, and metals as well in wastewater collection and treatment systems. As I mentioned, it's been around for some time. It's quite a mature product. It's been in the industry since 1991. And its main use for the most part is that in the US in particular, it's used for estimation and the reporting of air emissions across a number of industries. So we have a wide range of users of Toxchem, from consulting companies to industry professionals, universities and colleges, researchers and so on, and the APA themselves have a license. These are all different uses across the board, but for the most part, we know that there's a number of people using it to do the reporting of air emissions, as I mentioned, but also planning and designing of wastewater process schemes to be able to reduce air emission. You know, can we design this plant, or can we operate it differently to get more biodegradation and less loss of particular contaminants, either to the wastewater effluent or to the air. There are some people who use it for biosolids disposal management studies, looking at what kind of emissions you're going to get off of different types of biosolids treatment units. And a number of people use it sort of in the health and safety sector to look at trying to figure out what the concentration will be in a capped unit where there might be some possibility to approach, for concentrations to approach hazardous levels or possibly explosive levels. And generally, it can be used anytime you want to be able to track the contaminant mass balance across any type of wastewater treatment. So we find that Toxchem, the strengths of Toxchem as we understand it from our users, is that, well, certainly it's a very mature product, well-tested, well-proven algorithms that have come from a number of different sources and developed over time. We have a very comprehensive model library with over 50 unit processes, which I'll show to you here in a moment. Any number of different type of collection system units, wastewater process units, clarifiers, tanks, and different types of wastewater processes. And we also have a very large comprehensive organic database of over 800 compounds that you can put into your Effluence. So we've sort of scoured a number of chemical databases from a number of different sources, and so when you sit down to model what's going to happen at your wastewater treatment plant, most likely the things that you're looking to put into that Effluence will be there, and if they aren't, you can even add new things as you go along. We've updated the user interface for those who may have seen older versions of Toxchem. It was of a specific style of the time. We've updated it and given it a modern, easy-to-use interface. And of course, it's fully supported by Hydromantis. We offer training and support, and we continue to develop it, and will so in the future. So what I'm going to do is just give you a few slides here that's sort of a rough description of what Toxchem looks like and sort of what's under the hood there, just to talk about how we model the individual units, the individual contaminants as you put them into your model. And it has several different processes that act upon those contaminants, and it acts upon them each individually. We are, of course, modeling the biodegradation as the stuff comes through the plant. Each contaminant that you add has its own biodegradation constant, some for aerobic systems, some for anaerobic systems such as digesters, and there's some level of sophistication in that biological unit. We also then calculate through a number of models what the volatilization is, so the lost mass transfer to the atmosphere. And we also have sorption models to figure out how much of those components are going to be sorbed onto solids and then therefore removed through clarification and treatment and removal of biosolids. There are a few individual components that actually could theoretically be produced in a wastewater treatment plant. In any place where that's particularly relevant, we show those. And then we're doing, of course, a mass balance on everything, and we can then determine after all of those losses have happened, what is the amount that's leaving the plant through the wastewater effluent. So right now, the current up-to-date version of Toxchem is version 4.2, as shown here in this diagram. And as I mentioned, we will have a new version coming out later in the spring or sort of early summer, version 4.3. Each version of Toxchem allows you to draw out your plant by dragging and dropping a number of individual unit processes from our table. And then you do this on this drawing board. You then hook them all together and fill in a lot of the details for each one of those unit processes. It's all relatively quick and straightforward. You add your components in, your contaminants that are coming into that plant, and when you run a simulation, we have an overall fate summary down here in the lower left-hand corner that summarizes sort of plant-wide how much was biodegraded, how much was lost to the atmosphere, and how much went out in the effluent. We then have that same kind of breakdown done on a unit-by-unit basis, and this is new in version 4.2. We just added this in the release that came out last fall. A quick adjust panel, meaning that rather than having to, if you want to sort of do some calibration or some adjustment, a bit of investigation on a couple of the input parameters into the model, say like temperature or size of tank, rather than having to go back and forth, opening menus and changing menu items and then closing them and running the simulation, we've now added this new feature where you can put, you can pin a number of those input parameters into this panel, and they'll be there and allow you to very easily make small adjustments. We also are very proud of our large chemical database that is used to populate the flow coming into the plant. So I'll demonstrate this and show you some of the details that you can find on this shortly. And we also have what we kind of call our smart visualization of results. So if you want to, you can have the results color-coded so that the individual unit processes that are doing the most release of air emissions to the atmosphere are highlighted in red, and then there's some intermediate yellow and green levels as well. You can sort of control if you how you want that color coding to happen, what levels you would like, and that can be either done on a mass or a percentage basis. So for each unit process, you can take a look at what's coming in once the simulation's done, what models, what values were used. Many of these things are coming from the database and then may or may not be adjusted for things like pH and temperature. And then you can get an output for each individual unit in terms of what the total air emissions was. This is up at the top here, a percentage as what was coming out for the whole plant, or down below here, total air emissions in a mass flow form. So what I'd like to do at this point is hop over to my desktop and quickly demonstrate what Toxchem looks like, and build a plant for you and put some contaminants in it, and then you can sort of see how we do this in this software. So first of all, I'll mention that this is the drawing board that I mentioned earlier. You can see these individual unit processes here on the left. This is our collection of different types of input that we have. There's quite a number of particular models that you can use for different types of collection systems, open systems, closed systems, drop structures, and so on. We have various types of preliminary treatment clarifiers and separators and so on. Quite a long list here of different types of unit processes for biological treatment. That includes, sort of conventional activated sludge, mixed and plug flow and so on. And then also some of the things like MBBRs and so on, SBRs, things that are specialty units of that type. We have solids for solids handling, digestion, We even have some air treatment units that you can insert as well. Different types of solids, biosolids treatment units. These are some of the newer models that we just put in with version 4.2, such as the fly ash treatment and the incinerator and so on. And any other sort of collection of other types of units that are used to sort of set up your model in the way that's most realistic for your plant. So what I'm going to do here is I'm going to build a very simple wastewater treatment plant. I'm going to drag a influent, that's a regular wastewater influent coming into the plant. I'm going to grab a primary clarifier, and I'm also going to grab a biological treatment unit here. We're going to pick a diffused aeration activated sludge tank, and I slide to the bottom here to grab the secondary clarifier. And then what I'm going to do is zoom in on those. There, that's a little better. And you'll see that we can hook these things together. You can put these in whatever order you like, and it's somewhat a very similar process to our other software packages, GPSX and CapNetworks, where you draw out and make a plant of whatever complexity is appropriate. You can have multiple trains and flow splitting and so on. The last thing we need to do here in Toxchem is to set up some effluence. So because we're really concerned here or focusing on being able to predict the concentration and the mass flow of these contaminants at different types of effluents, that's required. This is supposed to look like a pipe emptying out into a water body, so that's our wastewater effluent. We also have to keep track of all of our solids as well, so the primary sludge and the secondary sludge come down to this truck here doing the sludge haulage. And then we also have an air effluent, and this is kind of a generic unit that you need to put all of your air effluent into. So any place where we have an open surface that's relevant for volatilization, we put those into one or more of these items here. So what I've done is I'm sort of gathering up all the air effluent into one unit. So you can still look at these individual volatilization results from the model, but we can also do it as a sum here in total. So once you kind of have all of those things in place, and we can do a quick check here to make sure we didn't miss any connections. Okay, so we're good. What we have to do next is to specify the characteristics of each one of these units. So I'm going to do the influent last here. So I'm going to start with looking at, for example, these clarifier units. We have to specify, of course, surface area and depth and the number of other bits and pieces here that are characteristics and physical sizes of those particular units. There are a few other details here for doing volatilization, and you can use this menu to split the flow if you have the flow going into multiple trains. So each one of these, of course, those menus are different depending on what the unit process is, but primarily we're concerned with the things that allow us to calculate the biodegradation, the sorption, and the volatilization. So we would go ahead and fill all of those in. I'm just going to leave them at the defaults for today. And then we have to specify the wastewater influent. So here's your flow rate, your suspended solids, your VSS to TSS ratio, all of those kinds of things that give us measurements that we need to do the calculation. Temperature, of course, is important. And then we pop over to this tab here, which is called Contaminants. So what I can do at this point is add as many of the contaminants as I like from our contaminant database. So you can see here, if I make this a little bigger, that this table right here, our organic chemicals, is the one that is the 800 contaminants and that are stored in our database that allow you to add this to our stream. So what I'm going to do is I'm going to grab a few of these that illustrate different types of fate so we can see. So first of all, I'm going to grab this estradiol, this synthetic estrogen, and I'm going to take let's see here, acetone, which I know is, of course, highly biodegradable. I'm going to take some benzene, which is, of course, highly volatile, and triclosan, which, of course, is a disinfectant. And let's do a metal as well. So I'm going to select from this table down here at the bottom cadmium. So you can put as many as you want. I've seen layouts that have 200 contaminants in there. You can specify their input concentrations here in whatever units that you like. I'm just going to leave these all at 100 for now. And then now I'm set up to run my first simulation. So first thing I do is I click on that button there to do the calculations. It iterates around a few times until it comes to a solution. So you can see here now I've got this finished that I can look at the results directly visually on this screen, and I can do that here by selecting any one of the particular components that I've added to my list. So when I flip to benzene here, you can immediately see that it is had quite a bit more loss to the atmosphere, more volatile emissions than the other things. And of course, cadmium isn't volatile at all. So what I can do is, if you look in this lower left corner down here, you can see this is our overall mass balance for the plant. It's a nice quick summary of where everything is going. So for this estrogenic compound, for example, we can see that 79% of it was biodegraded, and but almost 15% of it was lost to the sludge. So it was bound to the solids and taken out through the solids handling system. So let's contrast that to something like acetone, which was 95% removed by biodegradation, or benzene, which was quite a bit more, 3 or 4% here lost to the atmosphere. If we look at triclosan, which is a highly hydrophobic type of compound here, this is showing 99% of it was lost directly to being sorbed onto those solids and removed that way. So that's a sort of a very handy way to take a look at the overall plant mass balance. And then, as I mentioned, you can do it here as well in this long table for each of the individual unit processes. So for example, if I want to look at the activated sludge unit, I can see for triclosan that I had a certain mass coming in and a certain mass going out, and a certain mass of that was biodegraded. Not very much in the overall scheme here. So that allows us a nice way to look around. You can also get at those images that I showed you earlier here, more detail in terms of being able to output all the concentrations and flows and other aspects of this model directly right from this table. So lastly, I'll really quickly point out too that all of this information can be very nicely exported out by hitting our report button. You can choose which things you'd like to have listed in your report. And there's different formats as well. I'm going to leave it on the Excel file. I'm going to just save that out directly. And that popped up over here. I'll drag that over so you can see it. So this is an Excel spreadsheet. This is nice and handy for being able to export images of the graphs and so on directly to your reports that you would like to use. And of course, all of the other outputs have been arranged here, grouping them by contaminant, doing that overall mass balance table for each of the 5 contaminants that you have listed there, grouping them by contaminant and so on. So you can get at a lot of the data in many different ways. There are also other reports that you can do that are even more detailed than this, and you can go through all of those possibilities. I think we sort of covered off all the various ways of displaying the information that comes out of Toxchem. Right, okay, so what I'm going to do is pop back to my slides here. Continue on. As I mentioned, we have other output formats where you can arrange so that you can look at it on unit process by unit process as it travels through the plant. And so you can see here we have the different unit processes listed with the contaminants down the side. And many of those things can be adjusted and customized as you see and exported directly out to Excel. We also can import data from Excel as well, and that's particularly useful, as I mentioned, if you have a very large number of influent concentrations that you need to be able to put into the model. So if you've gone through the database and added a large number of those components, you can actually set up a spreadsheet where all of that information is listed in the columns, and that can be directly imported into Toxchem, and then the results of the model exported out directly. pause briefly there. I believe I forgot to show actually the details of our database. That was something I meant to illustrate here. If we go to the Toxchem database, you'll note here, I'm going to make this a bit bigger, that as we scroll through here, there's a large number of these items that are taken from various sources. For each one of those, there's a collection here of some of the physical properties of that particular unit. You can then come in here and look at the Henry's Law constant or other models that we use to look at how we calculate that volatilization. So for some of these, it's not relevant, but for most of them, we have stripping, we have sorption. We can use the octanol water partition coefficient, or possibly other types of equations that use to describe the sorption. And of course, we have biodegradation. We have some more information on this for certain compounds than others. We have for units for particular contaminants that dissociate, and we ask you to enter the pH. We use that as part of the volatile volatilization calculation as well. And then all the details for these particular components are taken and they're listed here. So if you ever need to know where we got information from for, say, a biodegradation constant, you can come here and pick up the reference. So the good thing is that we have a very large contaminant database, but if we don't have what you're looking for, or you would like to be able to adjust, say, this Henry's Law coefficient, you can actually create your own. So you can come down here, click on Create New Contaminant, and it will copy whatever one that you're sitting on there, and then you can enter in new names, new values, and edit that references list so that you can remember the details that you made when you changed that particular parameter. So you'll always have the original set that's there plus the new ones that you've added, and your individual new organic chemical database with all your new components can be exported out at any time and sent to somebody else if they need to run a layout that you have. Okay, so back to the slides here for a few final thoughts. We also have a number of other features in the software, such as an automatic sensitivity analysis tool where you can pick a unit, you can pick a particular parameter, and then you can look at the results while we vary that parameter over a certain range. We also have the ability to import old layouts from older versions of Toxchem all the way back to version 3.0. So if you were a regular user before and you still have those layouts, they can be imported. Not only the layouts themselves, but also the database can be brought forward as well. We can create now multiple layouts in the same file. That's often quite useful when you're doing sort of a what-if scenario, or you want to be able to compare two different types of designs or operations and compare them side by side, sharing the same contaminant database. We have a number of other features that have been added in the last couple versions of Toxchem. We have, as I mentioned, the pH effect, which is used in the volatilization calculations. We've updated and improved the back solver. So in other words, finding out what influent characterization will give you a specific target effluent concentration. We've added and updated some of the biological kinetic calculations. We've added some effects for long SRT systems. And most recently, we added in dissolved organic carbon as some of the information that you can enter into your influent, and then therefore it can be used as part of the sorption. So contaminants that have a particular affinity for sorbing onto DOC can be included in your model. So what we have aimed for here is a tool that can be used very easily to build a plant, to allow you to select contaminants from a large and reliable database, and then quickly run simulations so that you can observe